All right. So we're going to do the natural log function integration. All right. So as I said last time, the rule, right, was the integral of 1 over x dx is going to equal ln x plus c. So if it's 1 over x, it's always going to be that way. Okay. It could be written 1 over u du when we do the substitution. So that'll be the same thing, right? It may be written du over u. All the same. So let's get started. Not much to really talk about. It's more of just working, solving the problem. So the integral of 4 over x minus 8 dx. So you have to be able to, what's it called? You have to be able to spot that this is an ln type problem. So you use substitution, right? So I'm going to pull out that 4 and notice like, oh, I have 1 over x kinda, right? So we will let u be the bottom so I can introduce my, so I can use the natural log, right? So dx is replaced by du. We put it on top or on the side, doesn't matter. So that'll give us 4 ln u plus c, which needs to be replaced by ln 4 ln x minus 8 plus c. Okay. Any question on any of those steps? Does that seem clear? Is that okay?
Yes, give me 1 second, sir.
Can you explain a little bit more the last 2 steps?
From here to here?
Actually, the last one.
Here.
How do we get x minus 8? We replaced it instead of the u, or what?
Yeah, we're substituting. So we're using substitution from the last section. So we're letting u be the denominator. So that's replaced. And du is dx. So that dx is replaced by du.
Right, the u. I see.
And then you just use your formula at that point. And then once you've done that, replace the u with what it's supposed to be. Because u is just a dummy variable. We need to have it in x.
So you will be always the denominator, right?
For this section, yeah, for the most part.
Okay,
But in general, most of the time, yeah.
okay.
It's usually stuff on the bottom or inside of a square root or something that has a big power, stuff like that. You start to see a pattern. Okay. You guys cool on this page or not yet?
Yeah, it's that. Thank you.
All right. You remember partial fractions from pre-cal a long time ago?
Long time ago.
We were not gonna do that just yet, but we did do something that was called long division, you remember? With polynomials.
Yes.
So we're gonna have to do that on this one to simplify the question in order to integrate. Okay. So just do the division first before you start. So x squared or x minus 3 is going to divide into x squared plus 5x minus 5. So remember how we only divide with this piece, right? So you go x goes into x squared. So I'm going to make a little side section for my scratch work. So how many times does x go into x squared?
2 times.
All right, so if you're not sure, you just do it over here. It goes in x times, right? And then x times these two would give me x squared minus 3x, right? And then the algorithm says you need to swap the signs. So that'd be x squared minus x squared.
0.
5 minus a minus 3, which is 5 plus 3, right?
Mm-hmm.
Then you bring down the negative 5. And you start over. So now x goes into 8x how many times?
X7.
Right? The x's cancel.
Oh, okay.
So if you're, so it's probably best to just do it on this side to be safe, because you never know. So now 8 times that guy would be 8x minus 8 times negative 3 is 24, right? And then you subtract it. 8 minus 8 is 0. Negative 5 minus 24, that's the same as negative 5 plus 24. So 19. So that's my remainder because I can no longer divide by x, right?
Mm-hmm.
So what you end up doing is changing this fraction into 3 pieces. So x plus 8, which is the quotient, and then plus the remainder over the divisor. Right, that's how we used to write the remainders back then, right? They'd become fractions or decimals
Mm-hmm.
back when they were just numbers. So now you just integrate each piece, right? Because we have the rule that says you can integrate this guy, no problem. Integrate. So that'll be x squared over 2 plus 8x. And then this one, we have to do the substitution. But you can pull out the 19 and it's just a moment. So let u equal x minus 3. Du would equal dx, right?
Mm-hmm.
So that would become, so this is just, or this is already done, this left part. I'm gonna pull out the 19 here. Then I have 1, I have du over u, right? Plus c. So finally, we are done. Just replace the u, and that's it. Do any of these steps not make sense? Do you remember the long division and how to do that?
Yeah, now I remember.
Okay, so this will be maybe you may be rusty on this, so practice a little bit. Once that's done, you'll see that, oh, this is easier to integrate because the original was not. Okay. These are basic integrals, and this is a substitution, which is the ln type.
Can you slide down the book? Need to check on the. Yes, over there. Thank you.
Okay. You guys cool down that one then?
Yes, sir.
All right. Okay. So this is 4 over x ln x cubed. So this is going to require a double substitution. So let's start. What should u be?
Excellent.
No, that's too much. Has to be. Let's start with the innermost part. Let's start with the x cubed. Because if we do the whole thing, then d would be a product rule, which would be kind of crazy, right? And they should be pretty simple derivatives. So I don't have a 3x squared on top, right? So let's solve for dx. So now I'm going to replace dx with this. Pull out the 4. So I'm replacing this top part, or the dx if you like. Maybe this will make more sense. I'm gonna put the dx on the side so it's a little more clear. Not that it matters. So dx is being replaced by du over 3x squared. It's on the right side. And I have u equal x. So I right here have x ln u, right? But I still have a bunch of x's, so I'm not done here. So right now it's super weird. So I'm gonna pull out the 4/3, the 3, I mean, make it a 4/3. Combine the x's, so that'd be x squared times x, so that'd be x cubed times ln u, right? I don't really have absolute values, so should be just ln u there. Okay, but x cubed is technically u, right? Does that make sense?
Okay.
So I use substitution and I simplify the problem, but I still cannot integrate. So I need to do another substitution. So I need to say, you know what? Let W equal ln u. dw will be 1 over u du, right? So that could let me do this. So you see how this is the same as du over u, right? And that's right here, isn't it?
Mhm.
So that's going to be replaced by dw. So dw replaces that piece. W will replace the ln u. Now I have a simple integral. You see that? This is one of the more complicated substitutions I could. So integrate this guy and I'll give you ln w plus c. But I need to get back all the way to x because w is not what I was looking for, right? So that's the same thing as saying ln of ln u, right? Because w is ln u, which is the same as saying ln of x cubed. There we go. Now we're done. This is one of the weird. So sometimes you'll run into a question that you gotta be very clever on your substitution, and it's not obvious. You gotta think about it, and so you gotta do a lot of the substitutions until you get more comfortable. And then when you get to something like this, you can start to see it. Any questions on any of the steps?
I didn't get the first and the second, let's see,
Beginning?
over here in this area. The, where you get the 3x squared.
So that was just the derivative, right? To get
Okay.
du. So we define du, take the derivative of both sides. Then I noticed I didn't have a 3x squared on top, so I had to divide this out. So I'm replacing dx with du over 3x squared, but I should not have any x's. So this is a problem. That's why I had to do another substitution.
Mhm.
But then I noticed, you know what? Once I multiply this out, I could get everything in terms of u. Because I had a x cubed, which is the u, right?
Okay.
So I replaced this one and this one. So now everything's in u, which is what we wanted, but I still can't integrate it. So I noticed that ln u is on the bottom and the derivative is 1 over u, right? Which is
Yes.
right here. So I said, okay, well, substitution will work here. So w is on the bottom and the derivative of w is 1 over u. So that's going to be dw right there. See how I replaced it.
Mhm.
And once we get there, we just do the basic formula. Integral of this is ln w. And then we got to resubstitute all the way back to x because we did it twice.
Okay. Okay.
So, yeah, I saved the hard one for last. Because most of them are pretty straightforward substitutions. Like,
Mhm.
but once in a while you'll see one like, what the heck are they doing?
Yeah, it's a lot of use.
Yeah. But just when you practice the homework, it'll feel better, and then when you see one of these, it'll be more doable. But
Mhm.
you gotta do a lot of substitution first.
We're gonna have like this in the review or the test.
Oh, I'll probably have one that's an interesting substitution. I don't know about a double. Maybe I need to check. I haven't checked the exam in a while. I'll let you know when I look at it.
I was done.
Oh, I'm sorry. You're still looking at it? No
Thank you.
worries. But that's on for 5-7. So as you saw, it's all it is substitute and do a formula. Substitute, use a formula. That's it. The entire time. It's just sometimes substitution can be hard.
Good, thank you.
Now, 1 second. Okay. Let's move on to 5-8. It's the last section of chapter 5, and then what I'd like you to do is finish up the homework and start reviewing, since you have a bunch of time. Okay. Have we talked about the date for exams? I don't remember.
You said Thursday, according to the syllabus.
Syllabus, that's probably not right. Oh, like I'd open it Thursday, is that what you said? Like
Well, according to syllabus, they said on the 9.
I'll double check that, but I'm thinking, let's see here. Well, let me finish this first, and then I'll look at our schedule, and then we'll decide. All right, so here's the inverse formulas for inverse trig. So integral of du over the square root of a squared minus u squared is equal to arc sine of u over a plus c. Or if you prefer, you can write the sine inverse symbol, same thing. Du over a squared plus u squared is equal to 1 over a arc tangent of u over a plus c. Du over u, that's a weird looking u. There we go. U squared minus a squared is equal to 1 over a arc secant of the absolute value of u over a plus c. So all you have to do in these problems is make it look like one of those three and then apply the formula. So that may require a little bit of substitution or some algebra. And that's pretty much it. I'm hoping it's not too bad. It should be easy. It should be in like similar to the 5-7. I think that's what we did last time, last chapter. So the square root of 2 minus x squared. So when you look at this, which one does it look like? 1, 2, or 3?
Hmm,
All right, so let me make a little note here for all these. A is a real number, and A is greater than 0. So A is the number, right? And U is some variable. So if this is my number and this is my variable, which one does it look like? Yeah, it looks like 1, right?
Number one.
Yeah. So we just need to make it look like this. So what is the square root of 2? That's a silly question, right? So rewrite the 2 as a square, in other words, right? You agree that if a square root of 2 squared is the same as a number 2, right?
mhm.
So now it looks exactly like number 1. Do you see?
Yes.
So this right here is my A, and this is my U. So my integral will be, oh, my answer would be what? Arc sine of x over root 2 plus c. That makes sense? Any questions on number 1?
No. Looks simpler.
So yeah, that's pretty much all you're gonna do. Let's do another one. Square root of 9x squared minus 4.
Can you scroll up?
Yeah. Which one does it look like? 1, 2, or 3? Yeah, it looks like 3. So I need to make this look like some variable squared and some number squared. So that will be, forgot to write dx up here. So what's your answer now that we've rewritten the problem? This is my U. This is my A. So just plug in those numbers and letters right here. A and
Over
U.
3x squared. Okay.
Yeah, 1 over
Okay.
2. Then inside we have the U, right? And
Mhm.
that's it.
Okay.
Okay.
So, question.
Mhm.
How did you determine under the square root in parentheses, 3x was your u? And how do you determine your a?
So the a will always be the constant, right?
I always remember the constant, okay?
But it needs to be rewritten as a square. And then the variable will always be the other piece. That needs to also be rewritten as a variable squared. So when you first start, right? I see, okay, the numbers first. So then I look at, okay, which one has a number first? It has to be 1 or 2, but since it has a minus and a square root, it has to be number 1. So then I rewrite it. Hold on a second, my computer's kind of freezing up a bit. Okay. All right, I think that's pretty much all the examples I have. I think I have a couple. Wait, no, here's one. Yeah, this is kind of tricky. Let's do this guy. Okay. Square root of x times the square root of 9 minus x. Okay. So which one do you think it is?
Number 3.
Yeah, so let's start by rewriting this part right here. So you agree that that should be a 3 squared, right? Okay. So here we can do substitution to help us out. We could say, yeah, actually. Interesting, because let me look at the formula. Good, look at number 3. It's supposed to start with a variable, isn't it? And this one does not. Right?
No.
So it's not number 3. So we're gonna do some substitution to make it look like number 1, because it's starting with the number. So let u equal square root x. du would be, I take the derivative of this guy, that would be 1/2 square root x. Should have an integral here. Sorry, I'm getting really messy today. Okay, so get rid of that 2, so that'd be 2 du equal to 1/√ x dx. So I have that part. You know what, let me rewrite this, it's bothering me. Just make it neater. So it's gonna be the exact same thing, I'm just making it a little prettier. The question was the integral of 1/√ x times the square root of 9 minus x dx, right?
Mhm.
Then we rewrote it as dx here,
Wow.
square root x times the square root of 3 squared minus root x squared. Okay, so now we're doing the substitution. So this right here is 2 du, right? You see it? That's the same as this.
1/x.
The root x is on the bottom. So this will be replaced by 2 du. And then I'll replace this one with u. So I'm gonna have 2 du replacing that chunk, leaving me with 3 squared minus u squared. So now it's ready to apply the formula. So sometimes you have to do a substitution before you apply the formula. So this will become arc sine, 2 arc sine of square root x over 3 plus c. Then any questions on those steps? All right, you guys okay?
Yes. Outside.
Right, so let me look at the schedule. So we can decide our exam 1. Yeah, it looks like we're on track. Cool. So I'm thinking I'll open the test up. I mean, I can open up whenever. I can open it tomorrow or something, but I'll leave it open until the end of until the 12th of September. So you have time to review, practice, and bring questions. And I'm thinking when I see you again on the 8th, if you want to bring some homework questions or whatever, you can spend the whole time going over what's going to be on the test and maybe review a bit. Okay. And then if you don't, if you feel like you're ready, we can all start chapter 7 then. Okay. Oh, you guys, do you have any questions about anything or homework?
Until today. So you're gonna open the exam tomorrow?
I think so. I'm gonna try to open stuff up tomorrow, because I know once Friday comes around, I'm gonna stop caring. So I'm gonna do it tomorrow.
Okay.
And then we have Monday off, so. And so far, I'm pretty sure we're gonna go back, well. So this is what happened, right? So apparently the district and a bunch of people were meeting and they were saying like, yeah, we wanna go back. We want everyone to go back. President of St. Philip's does not wanna go back, but the chancellor says, you need to go back. I'm like, okay, so chancellor is telling us what to do. So then we met up and started talking about it. And then a bunch of people got infected, the people in charge when we were meeting and trying to make plans. So that happened. So then we're trying to, so they're just still talking about it, but officially they said we're going back Tuesday. But after all that, weird nonsense happened, they might, I wouldn't be surprised if we get an email on Monday saying, oh, never mind, let's just wait another week, right? So I don't know.
Mhm.
But they're supposed to be, they've made a decision. I just don't know if they're gonna stick to it. So what I recommend to all of you is keep checking your email and your Canvas, check both of them, your student email.
Mhm.
Check it on Monday, check it on Friday and see what they said,
Mhm. So in the event that we have to come back and many other people, they don't want to go back, are these classes still gonna be available online?
You mean like in the future, like other semesters?
Well, let's say something happens and well, because it's happening with my daughter. She's in a face-to-face class, but she said, well, I would like to see if I could get it online, like right now on Zoom. It might happen on this class.
Well, they do have, so I think from now on, we're gonna have face-to-face. We're gonna have fully online where you're by yourself watching videos, and then we're gonna have remote, so you can
Mhm.
pick what you want. But this
Okay.
one is supposed to be face-to-face,
Face-to-face, okay.
so I mean, I don't know if there's an option for you to change. I don't know if there's another class where you could switch to only remote with somebody else. Like, I don't know if that exists, but maybe.
Okay.
In the
Um,
case, in the case we're going forward face to face,
Hmm.
which room or which building are we going?
It's on your schedule, but let me check.
It's on
First, second floor,
room 119.
first floor?
I think you're right, but let me check
Okay.
really quick.
Science building.
Yeah, it's Science Building 119, right?
Yeah. Mhm.
So it'll be the first floor of the science building. Yeah.
I have to
119.
go.
But I mean, it's not up to me. So, I mean, I've gotten kind of comfortable being lazy at home, so I like it being at home. But I know some people prefer and need to be face to face. But I know officially this class was supposed to be, so it's like kind of like a lie, right? If we stay zoomed.
Yeah, I signed up for this class because it was supposed to be face to face, but then like halfway through, I just reminded like, oh, I think it's online. Now I
Yeah.
guess we're going back.
But yeah, we'll see. I mean, I think in the future I might request less face to face just because now it's an option. So, but we'll see how everything goes. I don't know. I think they're sending out rules and requirements about math stuff and testing and all that. But I'm probably
Yeah, also,
uh,
did they say anything about vaccination? 'Cause, like, I'm not-
well, I think the governor's I think put a stop to that already, so I highly doubt it, but I'll check. It should be in the email, like with the rules and requirements that they think they sent it to everybody.
Mhm.
Now, on test days or exam days, would you implement exam face to face, or we can stay at home since it's the exam, or how is that gonna be?
I'm not really sure. I was thinking the first one probably just let you do at home, but as far as all the other ones, I don't know. We'll see. I might have them. It might be still on the computer, but just be in person. You just write it on paper and turn it in. But we shall see, I suppose.
Yeah.
I'll let you know once after exam 1.
All right,
Yeah, but please keep checking your emails so that way you're not like surprised. Okay.
Okay.
I guess I think we'll stop here if you don't have any questions. And then
Well-
we'll can review some more on Wednesday, maybe in person.
Okay,
we'll see you.
okay, sir. We'll see you then on Tuesday, on Wednesday.
Yeah.
All
See
right.
you-
Good-
see you
good
later.
night, guys. Be careful
You too, man. Careful.
this weekend, okay?
Yeah, I will.
Okay,
Thank you.
thank you.